working group leader at the Potsdam Institute for Climate Impact Research. And my work is usually focused on the attribution and on future projections of societal impacts from extreme weather events, so floods, tropical cyclones, and so on. And usually I focus on the direct implications of these events, such as fatalities, damages, and displacements. But today I want to present a bit of a kind of a side project that I started during my PhD some time ago, and this focuses more on the question: what happens if disasters do not occur in isolation? So, because usually when we assess the impacts, we actually only look at the direct impacts and not so much on the long-term impacts, especially not if there are other compounding or consecutive hazards interfering. And this recovery is actually a very under-researched area. And the question I asked then was what actually happens if recovery is interrupted by another extreme event. So if there are any non-linearities that arise when a society cannot recover completely. And we approached this topic with an agent-based model that I will present during this talk. But recently we also did a kind of a literature review to see what other people already found out on potential non-linearities if extreme events do not occur in isolation, but in close succession. And I will introduce a few examples. We found how these impacts of extreme events increase non-linearly if they occur as consecutive events. And this is also related to the question whether there may be some kind of tipping dynamics that we can observe in within a society if we see an increase in this extreme event frequencies. So my talk is not related to any Earth system tipping elements. The external trigger of potential tipping would be a higher event frequency of floods or tropical cyclones, for example. Coming back to these examples of how society may be affected by these higher event frequencies, I want to present this very first, this first very simple example. So if one disaster occurs and causes the first small damage to a structure like a house or infrastructure, then this may not cause complete structural failure. So you may still be able to use this building, but obviously buildings and infrastructure may become much more fragile and are more likely to collapse if a second event occurs. So and then obviously our damage is not linear, but we have a very small damage under one event that we can compensate easily. But if we cannot repair damages in between, we may experience a severe structural failure. And this, if we have this perspective on recovery, then previous recovery efforts may be wiped out, and recovery may prolong extremely if we have these secondary damages occurring. And particular for critical infrastructure, this is pretty relevant because infrastructure is usually designed to compensate damage at one point. But under consecutive hazards, if infrastructure cannot be repaired in between events, the entire functionality of energy grids or transport infrastructure may fail. And in particular, there have been many studies that show that transport infrastructure in the aftermath of disasters is often are often destroyed, and this severely hinders the response to these events and increases fatalities, as first aid is not immediately possible. And this is particular prominent example under tropical cyclones, where we have this compounding hazards of wind and flood and severe rainfall. And another aspect that is quite evident under these consecutive events, we experience severe resource constraints. So on the community level, this would mean that human as well as financial resources as well as material may become very short if we have to reconstruct at different in different areas, or reconstruct from several events at the same time. And so this makes it quite much more difficult, obviously, to recover from several events than from an individual one. And on the household levels, many households may be able to recover from an individual event because they have savings, or they can take up loans. But under successive events, they are likely to fall into poverty traps, because obviously they cannot pay back these loans if they have to reconstruct again. And this is a bit this last aspect is a bit the one that I will going to present in more detail. So this question, how households which are affected by a series of extreme events, how they are trapped in poverty, and how this differs between different income groups and across countries. And this is what we actually aim to model here. And this is what we also want to link to the tipping point question. So I make use here of the definition by Milkerite et al. So tipping point is defined as a point within a social ecological system at which a small quantitative change triggers a nonlinear change in the social component of the system, driven by a self-reinforcing feedback mechanism that leads to qualitatively different, potentially irreversible state of the system. So the change in this trigger would, in our case, be a higher frequency of extreme events. And obviously within a society we can observe several feedback mechanisms, and it's quite challenging to decide which to model. This tipping point definition also proposes 4 characteristics of tipping points. So the first is this non-linearity, the abruptness, the internal feedback dynamics, and irreversibility. So the last point is a bit, it's challenging to address in the concept of social systems. Because it's difficult to say whether a state is really irreversible. So this is something I do not address so much in this work. What we assume here is that if we have these well-separated events and households experience an initial consumption loss because they experience a damage and they have to reconstruct and can consume less resources, they have a certain distance to the subsistence line. So the subsistence line would be really the amount of money necessary to conserve the basic needs. And we would assume that if for most households, if we have these well-separated events where one event occurs after another and I have enough time to recover in between, then most households would not cross the subsistence line and would be able to recover efficiently. So obviously there are some areas in the world where people always live under the subsistence line. But these we don't consider here in this example. This would be rather like a middle income household, which has some resources left to recover, but it's not living so comfortably far away from the subsistence line. So you see here, if we have if we have two disasters in succession here on the right, then we would assume that households experience an additional damage and they are forced to reduce their consumption loss a bit further. And this may cause that many households may live under the subsistence line. And obviously, if you are busy with satisfying your basic needs, you have no resources left for recovery. And this is what is reflected here in this very slow recovery that households have when they have crossed the subsistence line. So they are no longer capable recovering from their own resources. And so it takes disproportionately longer to recover. And under more extreme events, coming out of this poverty trap may become impossible. So this is what we define here as a household tipping. So these households really move from an independent state where they can maintain their livelihood on their own to households in poverty, depending on external aid to really come out of this trap. And looking at the entire systems and at the entire social system and the potential dynamics and feedbacks that may occur. So what we would assume here is that extreme events increase in frequency and intensity, that we have more affected households because they are more frequent and more intense, and that recovery is also slower because it gets interrupted due to the higher intensities. And this would cause that households that we get more households which live in poverty. And there are also these social transfers and public spendings that usually help households to come out of poverty and to support them. But if more households live in poverty, the entire system is challenged because there are less taxes, for example, available to support households and recovery. So this additionally increases recovery times. And obviously, we can implement coping and adaptation measures that counteract this cycle. So the question we ask here is whether we can identify household tipping in this case, tropical cyclone affected countries due to these recurrent events, and how does this differ among people from different income groups. So the workflow we employ is, so we first provide forcing data. So the forcing data actually aims to provide time series of shocks for affected households. And we bring together this hazard, tropical cyclone hazard forcing, and socio-economic forcing. I will explain this in detail in a second. And then we use an agent-based household resilience model that simulates the recovery of households under these subsequent shocks. And our model provides then direct and long-term impacts such as damages, income losses, consumption losses, and well-being losses. And then out of these time series and metrics, we can identify this household tipping. So first, looking at the forcing, we use the global historical database on tropical cyclone tracks, so IP tracks. We consider the time period 2000 until 2021, and we calculate wind fields along all these tracks observed between 2000 and 2021. And so we get for each event here these wind fields with spatially explicit wind speed. And for the exposure, we use a population distribution, I think from gridded population of the world. And as we also want to take into account country-specific income distributions, we make use of data from the World Bank. So for each decile in each country we are looking at, so these are only 3 examples, we get the average income of each decile, and we assume a unique poverty or a subsistence line across all countries. So you see, while in Mozambique, basically, all deciles up to deciles 8 live below the poverty line. In Australia, obviously, no one lives below poverty or subsistence. And what we do to provide this exposure data, so we assume that in each grid cell, we see the same income distribution. So we can only see these differences in income at a country level. So we don't know whether in a particular area within a country there's another income distribution than in another area within this country. So we just distribute people homogeneously across grid cells using this total population count and this income distribution. And then we intersect these people from different income groups that we have distributed with these wind fields for each of the tropical cyclone. And then we get for each country, we get representative households that experience a specific shock time series. So for example, here in decile 1, we have a few examples of hazard trajectories or shock trajectories that this household experiences. And to decide on the share of damaged assets these households experience, we use damage functions for TCs developed by Eberens et al. So this provides us with a damage factor that tells us how much of the exposed asset is damaged under a given wind speed. So we relate these wind fields with this damage functions in each of these world regions. And then we couple these shock time series for each of these representative households with an agent-based model. So I will present this agent-based model in detail. So the basic idea is that each household has a certain capital stock that generates income, and this income is then consumed and generates some utility. So we experience that households at a low consumption level, or at a lower consumption, overall consumption level, households have a higher utility because you have a higher utility once you consume the basic goods, and then with more luxury goods, the utility decreases. So when a shock happens, then maybe one aspect on the interaction of households. So households do not only have income from their own capital stock, but also from social spending, so from other households, and this also includes social safety networks. And if a household is then hit by some kind of disaster, we assume that the capital stock is destroyed to some degree, and this reduces income. And consumption is then reduced twofold, because income itself is reduced, and the household has to reconstruct its capital stock. So consumption is not only reduced due to the lack in income, but also due to this reconstruction, and this then causes an overall well-being loss. And the model decides on the recovery rate of these households by minimizing the well-being loss. So in formulas, this looks like this. So in general, we assume an initial damage that depends on the wind speed in this case. So a distinct share of the capital stock is destroyed. And then we assume that there's an exponential recovery with the rate lambda, and this rate is this lambda rate is then optimized. And we assume that income losses are proportional to this capital stock loss, and it's proportional depending on the productivity of capital, which differs between countries. So here we only assume one different parameter for all the countries. For each country, we assume a fixed productivity of capital stock. And so the income, however, is not only, or the income loss is not only caused by this loss in capital stock, but also, if other households are affected and which are related to this household and support this household, this income from this social transfers is also reduced. And this is some kind of household interaction we are considering here. And the consumption is then reduced twofold. So first for the reconstruction and due to the income loss. And some households may have savings that helps them to smooth these consumption losses and reduce their overall well-being loss, which is the aggregated utility gained from the consumption. And the well-being loss is then the consumption under recovery compared to an unperturbed consumption pathway. And this is what we then optimize. So this well-being loss is minimized to define this lambda. But this is not the end of the story, because we have here this basic model version, and we are really interested in what happens if people cross this subsistence line. And then as an additional constraint to the model, we assume that once crossed the subsistence line, or once people come close to subsistence line, they avoid to cross it. And once they have crossed it, recovery gets disproportionately inefficient. And so this is again this tipping point definition that we then use here, because to get an overview how this differs across the number of extreme events the society experiences and the previous income conditions, we develop here these country level tipping profiles for all the TC affected countries. So the idea is that we look at all income groups here. 1 is the poorest and decile 10 is the richest, and we build groups. So according to the number of experienced extreme events, and we define the share of households from this group. So, for example, from in the first deciles on the poorest group, under 4 extreme events, 100% of the households would have tipped, while under the 10th decile does not tip, no matter how many extreme events are experienced in this example. So this is just an idealized one. But yeah, these are then the outcomes we get if we look at real data or our model outcomes, let's say. So for example, in Japan, you see that that there are actually no households tipping, even the richest, even the poorest households, recover if they experience 3 events. But in India, you can see quite an interesting profile that we get. Obviously, in India, there are people living always on the subsistence line, so even under 0 events, decile 1 lives always under the subsistence line, so that's why it's completely yellow here. But yeah, for other income groups, then for the middle income groups, it gets quite diverse. So you can see that for the 5th decile, the share of households tipped increases under higher event numbers. And then you get different profiles for all these countries. So in Mozambique, you can see that many people are always living under the subsistence line. But for example, in Jamaica, these recurrent events are not such an issue for the richer half of society, but cause tipping in the lowest income deciles. What we can also do is then getting the overall asset damage, and you can see that in countries which are strongly affected by tropical cyclones, obviously you get higher damages. That's the US. And this also depends on the income group of the country, because you see higher damages in richer countries. And this is not so much the case when we look into well-being losses. Still, the highly affected countries, such as the US, have experienced highest well-being losses, because I do not account for the number of events. But you see, for example, in India, which experience actually fewer events than the US, you get much higher well-being losses. And here, this is the consumption resilience. So this is somehow normalized for the number of events a country experiences. So this shows us the damage compared to the consumption loss. So if this rate is 1, then my consumption loss is exactly of the size of the damage, and usually the consumption loss is higher than the damage. So the long-term impacts are higher, because you have this this need to recover all the damage, and you have the income loss because the loss in productivity of assets. And China stands out as pretty resilient here, but this is actually because we do not only take into account private assets, but also public assets which are not recovered then by the households. This is because we are using here a preliminary model version. So currently for the public assets, actually nobody pays, and China has quite a large amount of public assets compared to other countries, so that's why it's so resilient here. But it just would need to be adjusted somehow, so we're still thinking about how to do this, because somehow households would also cover, at least to some degree, the damage to the public asset stock. But you can see that countries such as the US or Australia have a much higher consumption resilience than India, for example, and also Indonesia, which is not so frequently affected, but it's not really resilient. Then I will look a bit into the differences in impacts within a country. So this is an example for the Philippines from a paper that we've already published with a model version, which only worked on the Philippines, but there was very highly resolved data input. So here we actually asked the question, how impacts increase if recovery is incomplete for different income groups. So here we look at the consumption and the well-being loss, and we here assume that for each event you experience the same impact. So assuming that all impacts, all the events cause the same impact, we compare how impacts change if households have no time to recover in between. So we compare this factual and this counterfactual scenario. So in the factual scenario, we see a shock time series which corresponds to the observations and causes this interrupted recoveries, and then we assume the same amount of events, but we stretch or we extend the recovery time so that the household always has enough time to recover in between. And then we look how the impacts, the long-term impacts, can be distinguished or differ from each other in relative terms. So here you can see that for the middle income groups, so decile 4 and 5, for example, here you would see that three overlapping events or events with overlapping socio-economic repercussions would cause as much consumption losses as 3 events, or even as much well-being losses as 10 well-separated events. So, and here you can see where this comes from. So this middle-income households are usually in this fast recovery regime if they experience an individual event, but enter this slow recovery regime when they experience multiple events, while rich households always remain in this fast recovery regime, while very poor households are in this under the subsistence line even at 1 event. We found that incomplete recoveries increases long-term consumption and well-being losses, at least with these model assumptions, and that in low and middle income countries, this may have led to tipping, mostly for people of lower income groups. Obviously, this is difficult to validate, but we're also doing some efforts there. And within low and middle income countries, middle-income households experience the largest relative increase in losses due to incomplete recovery. And this is actually an interesting point also for tipping assessments on a larger scale. If we consider entire communities, because these middle-income groups usually have a stabilizing role within a society, and it's quite worrying if these may be also trapped in poverty. Maybe it's not necessary to talk about the outlook so much when we can jump directly into the discussion. Thank you.